stream the live event. Okay, welcome to Pixel Fondue and Foundry here, live streaming on Thursday. Still have power in this part of California, so if we black out, then we know what's going on. Alan, do you have power over there? Obviously.
Fortunately, yeah, it never went off for us.
Yeah, I think we're just out of the at the danger zone here in Sunnyvale, but it's gotten pretty close. My kids are really hoping it would power out so they didn't have to go to school. For those of you who don't know, California is just like a light switch nowadays, so we'll see. We've got Michael McCarthy from Foundry again, and we've got Greg Brown, and the black hole right here with no video camera is Alan Hastings, hiding his identity. We are going to be talking about... Alan can program a ray tracer, but he hasn't figured out webcams yet. That's all right.
Very nice.
I think he figured them out. I think he just figured you got to put a piece of tape over them.
Yeah, right. I usually turn mine backwards. There's like a nice view of my wall when I'm hacking. So, okay, so this is the Moto 13.2 beta preview of the rendering features. And in particular, we're going to be talking about a path tracer that is going to be integrated into Moto, and this is what Alan has been working on for quite some time now, I'm guessing, and we'll get into that in a little bit. And then, Greg is going to show us a couple of the settings, how they're simplified, and we'll get into the details a little bit on how path tracer works compared to a ray tracer, the benefits we have, some of the light output settings we can do now, and sort of what to expect as this development continues as sort of a in progress software right now, and it's also available on the beta if you're a subscription or maintenance. You can actually download it and play with the path tracer right now. And I think to start, since we don't get Alan on very often, we're just gonna talk a little bit about Alan's history, because he has sort of an interesting history in this industry. I think you can sum up his history by counting how many SIGGRAPHs you've been to. How many SIGGRAPHs have... What was this last year? How many in a row was that? Or just in general?
Let's see. I believe it was 33 in a row.
33 in a row. Was that total?
I have not missed any since 1987.
Not missed any since Madonna was the #1
That's right.
singer. All right. So that gives you an idea if you're not familiar with Alan. I do think what I'll do, I think, is Alan has a pretty cool PDF here that sort of goes over his history and some of how we got started in the industry. And I'll spare him of his junior high days back here and some of his early model making and Star Wars influences, and maybe push ahead a little bit to the future. Through let's stop here. This is a kit bash here, right?
Did a lot of that. So basically, I'll just say, just to summarize my career, I saw Star Wars as an impressionable teenager, and that sort of set my whole career path in motion.
I'll spare him of his junior high days back here. early model making. Yeah. So yes, definitely Star Wars was a starting point for many of us. But eventually, you learned how to program BASIC, and you did some work for Lockheed here in Sunnyvale, where I live, and which is funny because a ton of people, a lot of my neighbors, my kids, friends, dads, and grandparents, really at this point, are a lot of Lockheed people. A lot of Lockheed people in this area still.
Yeah, I kept trying to skew my job there towards more and more computer graphics and animation, and it actually worked. I was able to talk them into it, and I'm also grateful to Lockheed for allowing me to quit and move on with my hobby job of selling graphic software. Right.
So eventually, you released a program called Videoscape 3D. Now I remember that because that's back in the old Amiga days, which I've got one in my office here somewhere. And
that was Amiga only, and not used a lot on TV other than the old show Max Headroom.
Oh, it was used on Max Headroom. Oh, all right. Max Headroom got a bit of a revive with Ready Player One, at least in the book. Yeah. And so Videoscape was your first. So again, Videoscape, something you programmed for the Amiga. But at that point, did you know, like, this is something I want to make a career out of? I want to pursue this.
I actually kind of wanted to be an animator back then, and I had an interview at PDI. But fortunately, in hindsight, fortunately, they didn't hire me, because
Right.
otherwise I never would have been able to go on to do Lightwave and all the other stuff.
Did you interview so for those of you who don't know, PDI was Pacific Data Images. It was in Palo Alto for, I guess that's probably where it originated.
Yeah, when I interviewed with them, they were in Sunnyvale.
Oh, they were in Sunnyvale. Okay.
And they were only 30 people. And of course now it's turned into DreamWorks Animation.
DreamWorks, so they released Ants, and I believe were acquired prior to the first Shrek by DreamWorks, I think.
I believe so.
And if you live in this area like we do, you know some people who worked there. And so wait, did you interview as an animator then, or a developer?
Actually, as an animator.
As an animator.
As an artist, yeah.
Well, that's awesome. I did not know that. Actually, scrolling through this PDF, there's some really clearly you had some artistic ability. I'm showing some of the drawings you had earlier with sort of Blade Runner inspired. It looks to me. This was maybe high school or junior high. The Verks.
I'm not seeing that on my feed.
Yeah, let me share. So again, we've got sort of this hacky Google Hangout plus OBS live streaming going on. So let me see if I could share my screen with everybody here, so Alan can see what I'm talking about. So Alan, you should be able to see my screen now.
Yes, now I can see.
Okay, this is much a better conversation now. So I'm sort of backing up to high school days. This high school when you're doodling around on the notebook paper?
Those are all drawn in class in high school, yeah.
All right, there you go. Yeah, exactly. You should have seen my folders in high school. They were just covered.
So my first Amiga animation was based on this Verks idea with these flying cars and things like that.
Right. So yeah, it looks a little Blade Runner-ish here. Maybe a little Y-wing right there. Obviously, yeah. So you were an artist, and then you were doing some programming, obviously at Lockheed, and then you programmed Videoscape 3D, and then at some point you were introduced to the toaster people who needed a program for the video toaster.
Right.
Which eventually became Lightwave. And how did you meet those guys, by the way? I mean, they were in Kansas.
It was at an Amiga convention.
Amiga convention.
They saw my Super 8 films being projected at Amiga Expo 86, I forget.
Oh, okay. So just sort of bumped into them, and you probably started a conversation, and yeah. Did they know you were the creator of Videoscape when they had?
This was actually before even Videoscape came out.
Oh, really? Okay.
Yeah, so I was basically showing my Amiga films at user group meetings, and that's when Electronic Arts actually asked me to interview and see if they would make that a product. They said it was too hard to use, which is actually true. As you can see by the graph paper there.
Right. So if you're, this is like really old school modeling, and this is when you really need to plan out your models. And so you actually drew these out on graph paper, and you actually numbered the vertices.
That's right. So first you have to figure out the coordinates of every vertex, and that's the paper on the left. And then you have to figure out what's the index of every vertex to connect them up into polygons. That's the paper on the right. And then you type all this into a text. You type all of this in a text file, and then you can load it into Videoscape, and then you get the next slide, which is the magazine cover I did with that model.
So, okay, amazing computing, and so you made that magazine cover. And those were modeled via text editor.
Correct. And there's actually modeled motion blur on those blades. It's kind of hard to see, but the edges of the blades are semi-transparent as fake motion blur.
Nice. All right. That is very old school. Modeled motion blur. And so, all right. So, at what point did you get sick of typing in your modeling coordinates and convince Stewart into creating a modeling program?
I think you volunteered to do it. I was actually kind of used to this method, but he did it, and then I used it for my first big film, which was Rush Hour, 1988.
1988. So So those of you that don't know, are new to Moto or new to 3D, Alan and Stuart Ferguson's history is most people know it as Lightwave 3D, but they actually both grew up in this area here in Silicon Valley and were friends in junior high or middle or high school?
7th grade, yeah.
7th grade. And so, eventually we're working up to, meeting the guys at New Tech who had seen these films at an Amiga convention and creating Lightwave 3D for the toaster. And so Stuart Ferguson was responsible for the modeling aspect of Lightwave. It was actually 2 programs, if you don't know. One was a layout and rendering engine, animation engine that Alan worked on, and the other was a modeler. And,
right, and he actually did a modeler for Videoscape before that.
Oh, he did? I did not know that. Did it come with
Right.
it, or was it a different program?
No, it was a separate product.
Separate product, right.
And I first used it to model the Golden Gate Bridge for the movie Rush Hour. For my film Rush Hour, that's before there was a mainstream movie called Rush Hour.
Before the Jackie Chan Rush Hour.
Exactly.
Oh, man, look at the jet and the... Did these models ship with Videoscape or eventually Lightwave?
I think some of them did, yeah.
Wow.
Yeah, these are incredible. These are awesome.
That is so cool. So, and you've even got the Lockheed Missiles and Space Company.
Oh, I might have borrowed a few pages from my...
Came home with a notepad.
Right.
That could be mistaken for a weapon, the one on the right. There's a new Lockheed's new fighter jet. Okay.
If you scroll down some more, you'll see some stuff from Rush Hour, I think, which was actually my first film shown at SIGGRAPH.
Oh, okay, yeah. So
at SIGGRAPH 88. Yeah, there's the storyboard.
There's a storyboard for Rush Hour, and this was shown at SIGGRAPH, like the Electronic Theater or whatever it was back then.
I was in the animation theater, not the nighttime show, but
animation theater.
I was still happy to have it shown at the convention.
And so you still wanting to be an animator, and so you're obviously were an animator. You created this film, you got the storyboards, and you've used, I assume, Stuart's modeler on this. And this is all Videoscape.
Yep.
And all of Amiga.
Right. The first version was Videoscape, and then I redid it in 1990 with sort of pre-Lightwave and much more color depth.
Right.
Videoscape, you only had 32 colors total.
That's right. So the old Amigas, which by the way was huge at the time, having 32 colors.
Right. Yeah, far better than Mac or PC at the time.
Right. Mac, you had black and white, and PC I think you had 4, and I think my Atari ST had 16 or something. So the Amiga won with 32 colors, but
32 colors with Amiga was epic.
Yeah. Right. So so this is it's so funny because it doesn't seem that long ago, but it was because surely some of the people listening to this are like, what the hell are these guys talking about? But right, so Videoscape, and then eventually going into full Lightwave development, which was still on the Amiga in the early days.
For quite a few years, yeah.
And there's
our first big show was Babylon 5, which was rendered, at least first season, on racks of Amigas.
Right, Babylon 5. Now, I'm glad you actually brought that up, because last night I was thinking about Babylon 5 because I just finished Season 3 of The Expanse, which, by the way, if you guys haven't seen The Expanse, you got to watch The Expanse. Have you guys seen that?
No.
Yeah, it's great.
Yeah, it's awesome. But it reminds me of Babylon 5.
Really? I didn't check it out.
It reminds me of Babylon 5 in that it's just science fiction coming from a different angle. It's not Star Trek. It's just the people into it are obviously really passionate about it. But anyway, it sort of reminds me a little bit of Babylon 5. And I was thinking about Babylon 5 last night. But
by the way, the guy on the right there is the founder of New Tech, Tim Jennison.
Tim Jennison right here.
Right, and the guy in the middle is Dan Silva, who made the program Deluxe Paint and also started co-started 3D Studio.
Oh, that's right, the Deluxe Paint, right, and he did do 3D Studio, which eventually became Max.
Max, exactly.
That's Tom?
No, that's the other one, Dan Silva and Tom Hudson.
Okay.
Right. Tom
Sort of
Hudson
teamed up on
was the Dega Elite, I think was the ST program I had. Yeah, gosh, wow. So, I mean, you could literally count these early pioneers, Alan being one of them, on your fingers, who created all these programs back in the day. And I'm guessing this maybe is an original toaster board or prototype or something on the right here.
That was the hardware that Lightwave was originally going to ship with, which is not a toaster. It's called the Chromodungle. It was a very low-cost, high color depth frame buffer.
Oh, okay, so you can get 24-bit images,
Right.
perhaps. Right.
Yeah, and in a very tricky way. It was pretty cool.
And there is Alan being married. It must be in Hawaii.
Yep, 1990 on Maui.
Nice. Sounds good. Do you guys, and his wife, lovely wife Robin, who I've met a couple times. And you guys head out to Hawaii still quite a bit?
No, not for a long time.
Not so much.
Yeah, there's me. Me at the keyboard of an Amiga.
Oh, yeah, Amiga 2000, typing away. And Newtopia. That is
right. I worked for Todd Rundgren for a while. Yeah.
Right.
In fact, that was one of our big breaks. Was his music video, "Change Myself."
Yeah, which
made with Lightwave.
Still looks awesome.
Right, and he also hired Ron Thornton, who became visual effects supervisor on Babylon 5. So it all ties together.
Right. Yeah, I actually saw Todd Rundgren up in San Francisco a couple months ago. He was back in town, and my wife is a big Rundgren fan, so took the family up there. Now I remember these images, Lightwave early years images, and if you notice the aspect ratio here is 4:3, because back then that's what we were dealing with.
That one in the upper middle is interesting. It's my first global illumination image, but it's completely faked. All of the GI effects are done with point lights.
Oh wow, interesting.
I mean, really, no one was doing GI back in 1990.
No, but it does have that look. And I remember these procedural textures, this image here. I was in college at the time and being just like sort of blown away by it. It really sparks the imagination. Back here in the early days of 3D. And so I'm just sort of fast forwarding a little bit. So, Lightwave obviously came out as a big success, and you've got some Emmy. It looks like an Emmy here.
Got an Emmy out of it. Yes, that's me and Stewart in the back, in the middle back there.
Oh, okay. There we go. And yeah, Stewart as well. And and so eventually you guys ventured out away from Lightwave along with Brad Peebler and made Moto. And the initial Moto 101, for those of you who've been with Moto for many years, didn't have a renderer, correct? It wasn't until Moto 201, I believe.
Yep. Yeah, it had one in-house, but it wasn't exposed to the user.
It wasn't exposed to the user.
It was already working at the time we shipped it. But yeah, you couldn't. The user could not access it yet.
Right, yeah, and here's actually the box of the original Moto, which I've got around my office here somewhere. So those old time Moto users had this, right? Shipping on CD, got the paper manual, got the paper box. Nope, nothing like this anymore. This is not how software is distributed now.
Yeah, we'd have big parties to stuff those boxes and shrink wrap them. All our friends and family would gather and have pizza and build those things.
And so when you started, would you call the Moto Renderer your third rendering project?
Yeah, I guess that's right. After Videoscape and Lightwave, and it was mainly designed to address a lot of the shortcomings in Lightwave, in terms of dealing with huge scenes, allowing micro polygon displacement mapping, better quality motion blur. There were a lot of things that I realized could be done better.
Right. So motion blur displacement mapping. You had a global illumination sampling technique that was innovative as well.
It took a lot of inspiration from RenderMan at the time. And but it sort of turned the RenderMan algorithm around backwards, which was just a crazy idea I came up with, but it actually worked, and we've been shipping it that way for I think we first started exposing the renderer in Moto in 2006. So it's been 13 years.
13 years. And so, the Moto rendering engine, starting, shipping in, I think, 201, and now we're up to 13, has been, has had some steady improvements, obviously, a lot of things over the years. Also, I should point out that in 201, back in 2013 or so, preview was sort of unprecedented. This iterative renderer that, you could interactively move around and adjust things in real time. There was a plugin on Lightwave that was similar, but really preview was the first thing I think really integrated into a major 3D package. Now everybody's got it, but you guys really were breaking new ground there.
Yeah, that was. People really like that. That's true.
Being able to make modeling changes and see a ray traced image updated in real time.
It was basically a different front end, which was done by Gregory Duquesne, but using the same ray tracing and shading code as the bucket renderer.
Right.
Just starting out with a very, very low res image and then refining it. So,
and that's continued to evolve over time as well. In fact, a lot of times, especially people making still images, will really oftentimes just let preview continue to bake away at it until something is done. And a lot of the path tracers, which we're sort of building up to nowadays, often pretty much work like that as well, where it just sort of starts shooting and keeps on building up, starts shooting rays.
Right. We call that progressive refinement, and that's pretty much taking over rendering, I would say.
Right. So, moving through the years of Moto, here we've got some Alan's. We could just talk. Alan likes cars. We could just talk about it. So that's Alan's Ferrari, which I've sat in once, and it was not made for 6'3" people. At least maybe the seat was pushed up a bit.
That's true. Yeah, it's designed for shorter people.
Yeah. So, and there's your cats. Maybe we can finish on the cat. So the cat on the right looks particularly angry. I don't know.
She always looked that way. She had a permanent grumpy face even when she's happy.
Yeah, that is hilarious. Okay. So that's this type of stuff people our age can talk about all day, and hopefully this is still interesting to people who are just jumping into Moto for the first time. I see some people like on the chat here are brand new users, so I hope this sort of history is interesting to everybody. But we've gone from building up like Videoscape 3D with 32 colors and typing and modeling coordinates by hand that you've done with a graph paper, up through Lightwave and all the generations of that through the years, and Emmy Award-winning TV shows, moving on to Moto, a renderer that's a sort of a third evolution of rendering with new sorts of advanced features inspired by RenderMan or along those lines. And now we're introducing sort of, I guess, your fourth large project, which is a path tracer, which is going to be brought into Moto starting with 13.2.
Right. We're just sort of showing it as a technology preview in 13.2. But it does show the direction that we're heading in. It's really, path tracing is really sort of the modern paradigm for rendering, and it's sort of taking over in all areas from stills, GPU rendering, all the way up to high-end studio rendering for film. It can do it all.
So, really bringing some new technology to Moto. And I think we should maybe approach this in a couple ways. Why don't we, maybe Greg or Mike can jump in and talk a little bit about sort of what we're doing at the big picture, integrating this into Moto as a technology preview and sort of where it's going. And then we can go back to Alan and talk a little bit about the nuts and bolts and differences between path tracing and ray tracing and what this new renderer is going to offer us. Does that sound like a plan?
Absolutely.
Okay, so why don't I jump back from here and we'll go back to people's faces. And Greg, if you maybe want to jump in and talk about how, as sort of managing Moto as a product and and putting it out there in front of a wide variety of users. How are you taking this new piece of technology from Alan and bringing it into Moto, and what are your sort of goals for that?
Well, Alan definitely defined a lot of the direction on that, having done all these, the previous render for Moto and previous render for Lightwave. Moto's render has been a bucket-based render, and bucket-based renders are definitely advantageous for producing animation, things of that sort. You're going to get a much more consistent response frame to frame. And so with our first implementation of the path tracer, we decided to actually implement this as a bucket-based render, and also build an entirely new framework around that, which I think was one of the smarter decisions, which is the ability to basically be able to connect different things into it in interesting ways, right? One of the big questions a lot of people have, they're like, oh, is this a GPU renderer? And it's not. And that's one thing that we want to be very clear about. It is currently not a GPU renderer. It's able to leverage the GPU in specific areas, like for ray casting specifically. But the way that it's been architected allows for it to be extended further as we decide we want to implement additional methods of rendering and different additional computing devices. And that even carries on further beyond to things like progressive rendering, because it is currently mainly a bucket-based renderer, but this is a framework that will allow us to extend this, and we look at it as future-proofed rendering solution.
Yeah, I think that's been my impression, having used the beta, is you have a system that is together enough now that you can start letting users, use it during this beta period and as a technology preview, and sort of see what it can do. But looking at path tracing in general, it's really several different components that make up path tracing, and we could talk to Alan about that a little bit as well. And there's different sort of compute engines you can use for these different components, whether it's raycasting or shading or shadows or whatever. And again, we'll talk to Alan a little more about that. There's also the shading aspect of rendering, and Moto has been around for a while now and has quite a few different material types in there, and some specialized materials as well. And so, could you speak a little bit as to the compatibility of the path tracer with the existing Moto materials and procedural textures, things like that?
That was one of the most important things, especially the procedural textures. One of the things we were definitely up against looking at, hey, how are we going to offer eventually a GPU solution? Is, are we going to throw out all this stuff that we built up through the years that, personally, I rely upon those procedural textures, things like, the occlusion shaders, stuff like that. Now, currently, the path tracer really only supports one material, and that is a big clarification. So some of the other custom materials, the standard material, and also the energy conserving, and also the principled, those are currently not supported. And some of the other custom materials like Unreal and Unity and stuff like that. But the basics of what you will use in the shader tree are just going to work in the path tracer. So you're not going to be limited by having to use only image-based textures, and that's really where we wanted to start out.
So,
yeah.
Go ahead.
Oh, I just wanted to say that was one of the most impressive things to me, is just so much of the way that you can layer and do things in the shader tree just kind of work. And that's definitely one direction that we're really looking to continue following up on, and just not ship something that isn't a holistic Moto experience.
Right. So for those of you out there, the default material in Moto is this physical material. So when you just add a material to the shader tree, it's the physical material that works with the path tracer. That's available in the beta. Procedural textures that come with Moto, all of them, really, right? All of them will work with the path tracer. Now, if you
also gradients, that was a major thing.
Oh, gradients do too. Yeah, I actually tested those out.
Pretty complex gradient functionality supported in Moto, and that's all supported in path tracer as well.
Yeah, so the gradient functionality in Moto is fantastic, really, because you can pick all these inputs to the gradient, whether it's incidence angle or displacement height or whatever, just from a drop-down list. And a lot of programs, you have to rig those things up. So it's great, and I did test them to this gradient support, which is supported as well. So you can get in and use it for rendering, right now without really a huge amount of shortcomings. If you use things like the skin shader or the hair shader, or you mess around with the Disney principled shader, or some things like that, they're not going to work. But
Currently.
And to be honest, like at some point, it may just make sense to make new ones, right, Alan? As opposed to
those actually might work to some extent, but the results might be different. In fact, the principled and physically based are actually really similar. They use the same specular BRDF, which is also known as GGX or GTR. That all means the same thing. So yeah, there's just it's almost more of a user interface matter where the parameters exposed to the artist are a little bit different between these different models, but under the skin they use a lot of the same building blocks to actually do the shading. So I think we will be able to support those other things. We've just started out with the default physically based as sort of the baseline.
Right, and in terms of, and we can get into this a little more detail. I'm just looking at the chat here, and somebody's asking about NVIDIA only. And again, you've created this so you can sort of plug in different compute engines to different aspects of the path tracer. Is that correct?
Yeah, actually, that's we're using a particular flavor of path tracing, which is sometimes known as non-recursive or wavefront based, and it's got a lot of great advantages over traditional path tracing, where you will send a path from the camera through the pixel of the screen. It hits, it bounces around, and you fully keep following all those bounces until the end, and then you move on to the next path. Ours works completely differently. You fire a large number of these camera rays that go through a large number of sample points in the image. That's one phase. Then you stop and you shade all of those points that you just hit. Then you can go back, and the shading process generates new rays, new directions that all those rays bounced, and that's a whole different a new ray tracing phase. So you're not, you sort of separated these ray tracing and shading stages, and that's fantastic for making them modular and replaceable and interchangeable. So what we've done to begin with is we've allowed the ray tracing phase to be replaced with a GPU ray tracing phase that runs on NVIDIA optics. But there's certainly room for other options for that phase. There's other ray engines out there. And likewise, the shading phase can be modular as well. So it's a great architecture for future proofing.
So let me just load up the current beta to give a little bit of a visual aspect to this. Also, it helps because Alan doesn't have a camera on, so we have to have something to look at while we're talking about this. I just have 13.2 beta, the same one anybody can download right now, and we've got a torus in here. And if you select the render item under renderer, you'll see default and path tracer. That's how you get to the path tracer. And one of the things Alan was talking about is the ray tracing engine. And here we're defaulting to Foundry SSE, which is a CPU-based engine, correct? What does SSE stand for again?
I believe it's streaming. I forget. It's an Intel acronym, but right. Basically it's SIMD. SIMD means you can compute multiple math operations at the same time on your CPU, and all CPUs support this for the last 10 or 15 years. It's a highly optimized CPU engine that I developed back in 2010 for Moto, so I want to say 601. It's similar to Intel Embry, if people are familiar with that.
Right.
So it's pretty good, but it's not anywhere near as fast as NVIDIA optics technology.
So you can, if you see the drop down right here, I can select NVIDIA optics, and I'm not going to do that right now. So NVIDIA optics requires the NVIDIA 2000 series GPU, correct? RTX?
No, it does not.
Oh, it does not.
No, it does not. And actually, I believe it's Maxwell and above is the architecture required. Maxwell so even though it does use the RTX execution strategy, and it will have significant gains on RTX hardware does not actually require RTX hardware. In fact, my main machine is a Pascal Quadro P4000, and I get huge speed ups with optics on that.
Okay, so optics is NVIDIA only, does not require the RTX series, the 2000 above. And if you look at the statistics window here, and again, this will be put up on Pixel Fondue later at a high resolution recording, but you'll see something called extension ray tracing and shading and sampling, and then also shadow ray tracing. These are different types of calculations going on. And the ray tracing engine, for instance, NVIDIA Optics will speed up this extension ray tracing aspect right here, correct?
Right, and also the shadow ray tracing.
And the shadow.
But it does help if you have larger buckets, so that the GPU really loves to have these big batches of rays to deal with.
And so, Greg, are you okay with just sort of continuing along this vein, or did you want to drive this?
I mean, this seems to be streaming just fine. I have a couple scenes I'd like to show. I don't know if it's going to actually pipe through easily, but I have a couple set up that might be useful to show. Do we want to try that? Yeah,
why don't we try that? So I just wanted to sort of answer the forum question, and I think what Alan was saying is right now you have a GPU engine, NVIDIA Optics, or you have a CPU engine, Foundry SSE. It's constructed in such a way where you could plug in another engine, for instance.
Right. There's other possibilities which I could mention or not, but people can imagine, I'm sure.
Right.
So. Other GPUs, other CPU engines. It's very modular. That's the bottom line.
Very modular.
Yeah.
So
one thing that's super interesting about this render architecture is the ability to plug those different things in and not being locked in. I mean, Alan was obviously spot on when he was talking about future-proof. So, we're definitely not trying to just produce another path tracer. This is something cool, and it's really something different. It's really exciting.
And one of my favorite webinars from a couple of years ago, where Alan was actually being interviewed about GPU rendering, and Brad was interviewing and saying, well, why aren't we doing a GPU render? And it's like, well, it's not mature yet, and we can get a lot more out of the CPU. And now it's mature.
Well, that's true. That's actually still true. There's it's not that it is mature, but it's also true that we can get a lot more out of the CPU.
There we go. So I mean, like,
there's almost I don't think we've hit any walls in any area, GPU or CPU. There's tons of room for improvement. And
we finally have these massively multi-core CPUs on top of it all as well, and so it's
right. The SSE option will be greatly benefited by those. It's very highly scalable with CPU cores. Yes, and the GPU option would have been completely impossible with the old architecture because the ray tracing and shading phases were intricately intermingled in a way that there's no way you could separate them out.
Yep, and so we got something that can move on in the direction of GPU as it continues to actually mature, I guess.
Right.
And,
exactly right.
And then something that right now is immediately viable, and we're seeing even significant performance enhancement benefits even on CPU only. You see significant differences between the default renderer and the current path tracer called MPath, which we need to emphasize. It is called MPath, lowercase m, uppercase p, path.
So I just want to clarify that converting the old Moto, the classic Moto renderer, to just convert it to GPU wasn't in the cards because of the way it was, the way it worked.
No, there's absolutely no way the old architecture would work on GPU. It would pretty much have to be a path tracer in some form.
So what we're doing, so one of the goals is, at the end of the day, the goal is to provide Moto users with a better renderer. And part of that equation is a path tracer, because it has some advantages over ray tracing, which Alan can get into a little bit. Part of that also is being able to take advantage of different compute engines, CPU and GPU, or whatever else might come down the road. So there's that. And so in terms of being offered to the Moto user, what does it give you? Well, it gives you a more advanced renderer that can take advantage of different compute engines, and this is going to be an evolving aspect, and can provide better images faster ultimately to the user. Is that a good way to sort of put that out there, Greg?
I think so. Absolutely, that's exactly how I would characterize it.
Yeah, I would I say there's actually a lot of advantages to path tracing. One of the main ones being simpler settings. I think we'll get into more of that later.
Mm-hmm.
Yeah, Greg, if you want to share your screen, there we go. And then what we'll do is we could talk about the settings and some of the other aspects of this. And again, hopefully this is we're sort of doing this double streaming thing from Google through OBS. So hopefully this is viewable. I think it'll look okay. Let me know in the chat if this is totally garbled or not. I think it'll be okay.
Yeah, I'm actually I'm abusing my Google gigabit internet right now, and I can see it up on YouTube, and it looks okay. But definitely complain in the chat. Let us know how this is going. All right. So right now, these are just a couple renders that I ran off today to kind of show off some of the distinctions between the default renderer and the path tracer, and some of the advantages of the path tracer and path. And right now, you can see that I'm in the render item, and as Greg had pointed out, all you have to do to enable it is come over to renderer, path tracer, underneath the frame or underneath settings, and define which ray tracing engine you want to use. And if you're familiar with Moto's default renderer, there were a lot of settings. I'll go ahead and switch back on over here to default. You notice that global illumination is immediately exposed, the global illumination tab, and there's a lot that you would have to work with. And we had lots of really great features like irradiance caching. Irradiance caching was awesome. It definitely accelerated things dramatically, and really cool features like second bounce only, which kind of mixed Monte Carlo and irradiance caching to get better quality. But these are things that you had to know. And the settings tab right here for the default renderer, I mean, I think Simon's one of 3 people who could explain it all, who isn't Alan, And so I got pretty good with it, but that was as an artist who used it all the time. And so if I come back over here to the top, and don't you just love these scrolling forms in the 13 series? Thank you, Joe. And come back on over to the path tracer. It is dramatically simplified. And so the first thing that we have is the maximum quality. And so for maximum quality, right now I have this set to 256 samples, right? And so all this really is, it's anti-aliasing and the primary quality control kind of combined into one. And so the thing that's nice about it is there's actually a minimum quality that's not exposed. And when I go ahead and run a render, and I'll go ahead and come on over here to an actual faster scene that I have available, and come back over to the render settings. I have that at 128 on this one. One of the things you notice when you actually run a render in MPath is it's kind of iterative. It goes and runs pass after pass after pass. So starting with one sample and moving through each subsequent iteration up to 128 and refining the image over time. And one of the nice things about this, if I go ahead, abort the hood and abort for me, you can see that it actually stops at that level that it was at, which is very nice. Now, the noise threshold is another interesting one here, because this actually ties into variance. And if I come up here to my outputs, I actually need to have a whole render complete. So I'll get and run that through.
You can go to one of the old ones.
Oh, that's true. There you go. And we'll just go ahead and abort this. Yep. Come back over to this one. And we'll come on up to the variance output. You can actually see the noise in the image. And so it's detecting the difference between pixels and essentially at what point it wants to say, hey, we're going to skip. And so that's one of the advantages of the maximum quality setting, is that once underneath a region, 2 pixels basically have reached the correct level of the correct noise threshold, it'll be skipped. And as you continue going on through additional samples. So it's a nice optimization. Now, depth is, of course, it's pretty self-explanatory. That's basically the maximum number of bounces that you're going to be experiencing.
Greg, can I clarify something with the noise sampling,
Sure.
just so we're all making sure everybody's following along? So essentially what you're doing is you're inputting a percentage there in the noise threshold. And while the path tracer is rendering, it's comparing these pixels and looking at the noise, correct? And if it is under the threshold, it keeps rendering, but until it's no longer in the threshold, and then it's done?
If the noise is above the threshold, it will continue adding samples to the pixel. If the noise is low enough, then it's considered done. That part of the image is done. So very plain areas of the image or background areas of the image will be done early on, and it won't waste any more time on those areas.
So if you have a shoe on a white plane and you have it set to 256 samples, but the white plane, the noise threshold is down 5%, it's sort of a quality control. Once it's below that, it just stops blasting samples at the plane because it's not going to make any difference.
Exactly, yeah. Yeah, so the idea is to put the effort into where it's really needed.
Right. So it's an interesting a sort of method of speeding up your renderer by allowing the artist to set a threshold, sort of a good enough threshold for parts of the image, where then the samples can be concentrated, the compute power can be concentrated on parts of the image that really need it.
That's exactly it. Yep.
Okay. Okay, Greg.
Cool. All right. So, and depth, the number of bounces for specifically diffuse, reflection, and refraction. This is going to make a difference with your contact shadows, things of that sort. For diffuse and reflection, how many bounces you're going to get. Reflections actually producing a reflection on an item. So, scenes with lots of different items that could be reflected on a surface, you may want to raise that higher. And refraction depth, which you're going to see this probably be the most notable depth setting with transparent items, and how many rays are going to actually refract through a surface. And you'll notice it in particular with this image here. If I bring this on up to 100%, this really requires a setting of 12 in this render, because you have an outer glass element that has inner and outer glass and is passing through two sides, so that's 4, and then an inner region that actually has some liquid, and so that's going to be, it's actually a solid, so that's actually 2, and then you have this inner tube that has inner and outer, so that's another 4, so 10 minimum. But then when you raise it up to 12, you actually see more of the clarity in those outer corners. And this is the actual path traced final render, which is you can see it has a very distinct and different look. Can you explain some of the differences in refraction, Alan?
Yeah, well, basically we're trying to do everything in a more physically based way in the path tracer. And you have the way the Fresnel works is different. It depends on the relative refractive index in the material that the ray is in and the one that it might be exiting into or reflecting off of.
There you go. And so
it's just computing it more accurately.
There we go. And lots of the alpha testers that were playing with the path tracer were surprised at how much better their glass looked. It just looks more accurate, looks more realistic. And so that's one major benefit you're going to see. And the path threshold. And so the path threshold, basically, it gets rid of any rays that don't have an impact on the final rendered image.
Yeah, it's a way to trim down how many bounces you get so that you're not wasting time on rays that are not going to affect the result that much. It's sort of an alternative to those depths. And it's completely unbiased. So you can you can set the depths really high, and raise the path threshold if you want to speed it up, and it'll be unbiased.
Mm-hmm. There you go.
Which means no systematic error.
Awesome. All right, and of course, environment importance sampling and indirect caustics are here as settings. But one of the things that we're trying to do is we're trying to simplify this as much as possible. These are your settings for rendering, and they could even be simpler. Like EIS or environment importance sampling could actually be automatically detected. But we also want to give people who want that deeper access to those controls. And in the future, we're going to be looking towards moving more advanced controls into the schematic view and simplifying the UI further. But that's one of the big balances with trying to design Moto these days, is as it's grown and grown and grown, and like how do we make this easier to access and maintain that higher level of control and power that people want. Now, let's come back to this. This is actually the default renderer, and I kind of wanted to point out some interesting things with simple scenes like this. I mean, this is super simple. One of the things you're going to see the most impact using NVIDIA optics in particular is with interiors, and also just with the path tracer in general. You're going to see a much better interior scenes, and optics seems to really do really well with that on top of it. But as I move on through, this is an image with depth of field, and here's one without depth of field. And you'll notice that the depth of field image actually does take, or excuse me, I'll have to go back. Here's the no depth of field and depth of field. So depth of field takes, about 50% longer to render on the default renderer. And if I come on over here to the path tracer, about 5 minutes for the no depth of field image. But if I go ahead and switch on over to the image with depth of field turned on, it goes from 5 minutes 8 seconds to 5 minutes 13. So it seems like depth of field doesn't have nearly as big of an impact on render times, and so much more accurate renders without the same degree of cost. And I think that's pretty significant. And if you turn on optics, in this case, we go down from 5 minutes 13 seconds down to 3 minutes 48. And empath seems to do best, or you see the biggest difference while using optics with empath in complex scenes with lots of geometry, or scenes where there's a lot of bouncing like interiors. So you'll see even bigger gains along with that.
So what you might want to focus on, if you look at the empath statistics over on extension ray tracing, it's 20 seconds. And then if you go over to SSE, is this one SSE on the left?
Right here, come on back here. This is SSE.
So 46 seconds. So
yep.
Using optics, more than twice as fast. Choosing that option just over in the drop down if you've got a NVIDIA hardware. So,
yep.
Yeah. And I've actually tested that on some pretty complicated scenes. I think I had one.
Yeah, you had a good interior scene that was pretty abusive.
Yeah, and it really, the more geometry you sort of throw at it, it really, maybe it's this vegetable thing. Sort of the more geometry you throw at it, it seems like the more of a speed up you get. Is that true, Alan, or something along those lines?
You'll see the biggest gains in scenes with high complexity and geometry, and lower complexity in shading, since of course shading is still in the CPU. Now there is some extra time with optics to transmit the scene to the GPU, but it's usually just a matter of a couple seconds.
Right. And is the shadow? Go ahead.
In a super quick small scene, it's not going to benefit you much. But big resolution, big sample counts, then it's going to help you that much more.
And a larger bucket size you mentioned maybe helps that.
Right. Actually, larger buckets definitely help. Optics really loves to have these huge batches of rays to work on.
So yeah, it seems like 64 by 64 was kind of optimal value considering.
Yeah, we're thinking of making that the default for the path tracer actually.
Yeah. And another thing that's interesting to point out, one of the big advantages for path tracing in general with empath is light passes, right? And because previously when you wanted to do light passes, you had to render out separate images, and those separate images were absolutely, it was a new render every single time. And with empath, we're actually able to do all that inside of one single render. And so you can see right here, I have all these light path expression outputs. These are for all the individual lights that are actually in my scene. So I have like 12 lights here or so. And all those come out all at once. And as I look through my render outputs, I'm able to go ahead and cycle through here and see each of these individual light passes all done in one render with virtually no render overhead. And so this is definitely advantageous for look developing and being able to actually tune lighting in a scene, because in a compositing workflow, these are all accessible and can be used to build up the shadows, or the lighting on a surface, which is hugely helpful. And if you want to know how to use that, first off, light path expressions. This is a new render output in Modo, and you can enter in an expression that defines what is going to be rendered, which is a great pipeline tool. But if you want to use this yourself and you don't want to learn everything about light path expressions, but you want to have those light outputs, we'll just pretend I don't have these added already. All you have to do is come up to render, add per light render outputs, and it will populate that in the shader tree for you, and you'll have access to those per light render outputs.
So do the light path outputs work with emissive geometry as well if you have...
Yeah, basically there's an expression in each output, it's a whole language that you can define how many or what happens at each bounce. It's much more than just per light outputs. It's a syntax that was started with the Open Shading Language project. There's lots of references online.
So the Open Shading Language or OSL, is that what you're talking about, Alan?
Yeah, That's right. Yeah.
OSL, I think,
Yeah,
was initiated by Sony Picture ImageWorks maybe, and then
Correct.
opened up kind of like Alembic and all those other types of things.
It's kind of related to this drive towards standardization within the visual effects industry, but it's been adopted by a lot of the major renderers out there, and fortunately, the language is somewhat standardized, and we're following along with that. So you can find references even for other renderers that will give you examples that will work with Empath.
So can we just stay on open shading language for just a minute? So it sounds like it supports that. So any sort of not just a light path expression or various lights, but you could probably get any code, any sort of render output that you want using OSL.
For light path expressions, yes, but OSL in general goes beyond that, which we don't support yet. However, Empath does, it was inspired by the OSL paradigm.
Okay.
So it opens up the possibility of supporting OSL shaders in the future, which would be great. I would love that.
Well, I've seen more of that. I noticed like Octane is starting to support OSL shaders, and I believe V-Ray as well. So it does sound like maybe it's starting to proliferate sort of throughout.
Yeah, it's also a similar paradigm to NVIDIA's MDL. Both of these, OSL and MDL, have taken up the viewpoint of let's split apart the deciding what rays to trace. Let's split that from defining what the surface, how the material behaves. In the old days, a shading language and a shader would do everything. It would compute all the parameters, then it would fire the rays, do all the sampling. That's how old school RenderMan shading language worked, for example. But now the idea is no. Let's let the shading language only specify sort of the parameters of the surface, and let the renderer itself figure out how to best sample that and what rays to actually trace. So the Empath is following along within that paradigm, which would make it easier in the future if we wanted to support those shading languages.
Right. Okay. Sounds good. So yeah, possible OSL or MDL support in the future, and sort of future proofing a little bit there. And,
exactly.
And so that's actually a really interesting aspect of this. So the shading. So it's not just the tracing of rays, but the actual materials shading there's some new stuff there as well.
Right. The path tracer breaks that up into these two phases of computing the parameters and then actually doing the sampling. Those were mixed together in the past, both in Moto's Renderer and others, and now the new paradigm is to split those apart, which gives much greater range for the renderer to optimize things.
Yeah, that's a really interesting idea, and it's exciting from a user perspective where, if some of these other sort of open platforms like OSL or MDL take off, and right now you can go jump on Wikipedia and read about OSL. I think Sony has a page up there. MDL, definitely NVIDIA will have a bunch of samples up there as well. But if these proliferate throughout the industry, then you should be able to get essentially OSL or MDL textures or materials that could work with whatever engine supports them, correct?
Right. Well, Empath positions us better if we decide to support those in the future.
Right. Okay. So what do you got going over there, Greg?
Kind of last thing to touch on, just kind of a general path tracer workflow thing. The maximum quality, we do have the ability to go up to 4,096 samples, and people are going to do that. When really one of the things you want to do is start using, some kind of denoise. And in this case, I'm using the NVIDIA Optics Denoiser, and you can see the difference that this has. This is with Optics Denoise and without. And so really what you want to do is find a reasonable maximum quality, usually no higher than 512, and then run denoise on it after the fact, so you don't waste too much time on just casting all these rays and rendering out these very complex scenes. So definitely one of those suggestions we want to throw out there.
So where's the denoiser added in the UI? Is it per
that
output?
Is It is per render output, and so right here you can see we have denoising underneath the final color, and so any of the outputs that you want to add it to, you will need to go ahead and add denoising to it. And so there we go. As we cycle on through here by gang selecting these light path expressions here, I added NVIDIA Optics denoising to all of them, and I won't run this render again because if I do, I won't be able to hear you for another minute, like just happened while fortunately you and Alan were talking.
Well, I think it's important to point out that denoising is a almost always on checkbox now for a lot of rendering engines. And it seems like denoising, every time there's another SIGGRAPH, there's been some pretty big advancement in denoising. It seems like that's really come a long way in a very short time. And I think that's just going to be a standard part of rendering now. And it really does cut down on render time. I mean, I think
it does.
Yeah, that's basically noise in a path tracer. Or any Monte Carlo rendering goes down sort of with the square root of the number of samples, or no better than linear with the number of samples. So with the square root idea, if you want to cut noise in half, you might have to crank up the samples by ×4.
Right.
When you get to that last phase where there's just a little bit of noise that you want to get rid of, it could take a huge number of samples to get rid of that last little bit. So why not use denoising instead?
Yeah, absolutely. And I think I use denoising all the time in my renders, and it sometimes has some issues with when you're going through multiple transparent objects or something like that. It can sometimes give you results you're not looking for, but in general, denoising is just a huge sort of always on checkbox and part of a workflow now. So we've talked about denoising. We've talked about the difference with shading and tracing. Is there is there like a 2-sentence difference that you can explain, but the difference between a path tracer and a ray tracer, Alan, or is a path tracer just a kind of a ray tracer?
Yeah, well, they both use ray tracing, obviously, but path tracing is sort of simpler. It's more brute force. It wasn't practical in the old days. We had to use a lot more tricks. It's just less tricks. It's more straightforward. I would say we've talked about simpler settings. That's a huge one. Ease of use. It's more amenable to physically based rendering, unbiased, which means no systematic error. You don't get glitches in animations. The only error is noise, and noise predictably goes down in a predictable way with the number of samples. It's single pass. There's no photon map or irradiance cache pre-passes. You get progressive refinement. You get great scalability with GPU cores. You get great modularity to swap in and out different GPU or different ray or shading engines. You get light path expressions. What we didn't mention is when you're doing per light outputs, that includes all of the indirect bounces as well from that same light. That's something that would have been completely impossible to isolate in the old renderer. All the indirect bounces would have been all mixed up.
And
compatibility with the modern shading paradigms like OSL and MDL. I mean, there's just I'm sorry, I can't make it a simple sentence, but there's so many advantages.
Those are all benefits of path tracing over sort of the standard ray tracing.
Right. There's just one. There's basically only one disadvantage, which is render time and noise.
Right.
Which are sort of the same thing.
And one thing that's being brought up in chat that Shane is, of course, addressing instantly is, what about post-process? Like, can we have a post-process? And that is, of course, not something that we can commit to on a timeline, but it is very much on the forefront of our thoughts in the future. We definitely can see the value of letting people do this as a post-process effect instead of almost baking it into the render itself. So we have a lot of workflow enhancements that we do want to emphasize that we are working on and you are going to see in the future.
And so you could integrate another denoiser like the Intel denoiser as well.
Sure. Good.
Yeah, that's fully modular as well.
So that's modular.
And there's also, I would want to emphasize, a huge opportunities for speed improvements in path tracing. When you have these big ray batches, you can do things like sorting all of your hit points and shading. For example, all all points involving one material all at once, including its texture maps. So when you're done with that, you can unload those texture maps from memory, load the next big texture map. It basically allows much more, it makes it feasible to have much more texture image maps than you could normally fit in memory.
So, right. So one of the advantages, you're able to use really large textures, and is that due to just the bucket-based aspect as well, or
it's just because of you can sort and deal with. It's sort of a streaming architecture where you can deal with all the points that you need this particular image at one time, and then move on to the next image. Whereas in the old renderer, all the references to various images would be completely mixed up, and you would need all of them in memory all the time.
Oh, interesting. So images are basically brought in, get the data you need from them, and then they can be kicked out and freed up the memory.
Potentially. We actually don't exploit this quite yet.
Right.
This is like a future enhancement, but it's made possible by the path tracing architecture.
Oh, interesting. Okay. And
it was actually the number one motivation for Disney to adopt path tracing in their latest in-house studio renderer.
Oh, because of all the vast
because they have literally hundreds of gigabytes of textures in their scenes. There's no way you could put them all in RAM at the same time.
Right. And path tracing takes care of that. That's cool. I'm sharing a screen right here. This is rendered with the path tracer. I just did this right before the live stream, but just in terms of depth of field, if you look at this spiral right here in the front and how like delicate that depth of field is, and like Greg noted earlier, it just kind of came along for free with the sample settings on this scene. This is also showing the gradients are working in this particular path tracer at this point, so you can use all the gradients and input parameters in Moto right now with the path tracer. I also wanted to point out, like, this would be a prime example, I think, Alan, correct me if I'm wrong, where you could use noise threshold, where a fair amount of this image is just, these white areas. And
you're right. It's going to be done with that pretty quickly, and it won't waste any more time on those areas.
Right. So while there are very few settings now, which is great from a user perspective, a lot of times I notice people with path tracers, the only thing they ever really seem to mess around with is just the number of samples. But you have an opportunity to sort of just adjust one or two other settings, both the noise threshold and the path threshold, to really take care of it. Big wide areas like this, and have them wrap up quickly once the noise hits your threshold, and then just move on to all this stuff here and concentrate.
Yeah, and in my ideal world, the noise threshold, that's really your one setting.
In your ideal world, that's the only thing you really want to...
Right. The maximum quality is sort of a cap on that. But the real quality setting would be noise threshold. And ideally, everything else the user would never even have to look at.
So we may get that at some point. And so...
Right. That's what I'm striving towards.
And so, and again, just looking at this scene that I have up here, when you hit render, and you'll see these buckets going and going and going, it almost looks like a progressive renderer, like you would see in a preview or something, but it's a bucket-based version.
Yeah, but it is progressive as well.
So it just
means
right. And so along those lines, so obviously people are going to want to use this in a fully progressive window, like the preview window, and all the advantages that the preview window gives us in Moto. So are we going to be able to do that at some point?
Yeah, absolutely. I think one of the main things we're lacking right now is the ability to actually go ahead and stop it when you're satisfied and save it. Shouldn't be too hard to add that, but we don't have that quite yet.
Right, and so for a lot of people who just do still rendering, they kick off a progressive renderer, and then they just watch a YouTube video, then they go back and go, okay, looks good, and they save it off, right? And so you don't even really, back to Alan's point, you're not really adjusting the number of samples. You could put it up to 1 billion, because you're just really going to stop it whenever you want.
Exactly, yeah, that is the ultimate workflow.
Right, and so, yeah, noise threshold, and it would be interesting just to have this all sort of dialed down. Then we could just have a slider. Right, there we go, right there on the screen. Well, is there anything else you wanted to mention about this, or do you want to see if there's some questions? Stop sharing. some questions that we have from the chat window in the last part of this live stream here.
Yeah, I think we should take a look at some of the questions. Greg, did you have some comparison images to show that kind of shows how the default renderer and how Empath are working?
Yeah, in the document I gave to you, Greg. God, it gets confusing.
Double Gregs.
Yeah, double Gregs. Somebody needs to have 3 Gs instead of 2.
This one, or the one with the Porsche?
Yeah. If you go down to the interior, that was one of the more interesting comparisons because, again, interiors really seem to shine because you get a lot of bouncing. And I believe the difference in speed was from 1 hour and 40 minutes for Empath to 6 hours for the default renderer. And actually, it seems like many ways much better quality with Empath as well. And definitely, Michael and I were really kind of geeking out over that one earlier today.
Yeah, I did notice this. I noticed the vase disappears, so Empath cannot render vases, apparently.
Yeah, that's one of the big shortcomings, sure.
And so it is a little. You'll notice that there's a little more diffuse lighting going on in the Empath renderer, and I think that may be due to the number of default diffuse bounces.
Right, there is a different default there. Empath is much better able to handle deeper bounce levels. Than the old renderer.
You're going to notice a much better distribution of noise, when comparing with a Monte Carlo renderer and the default renderer. That's one of the things that a lot of the alpha testers really keyed in on repeatedly. It's actually something with Michael's experience in renders in general, you had a lot to say about just the distribution of the noise and how that looked compared to other renderers, right, Michael?
Yeah, the distribution of noise is very even, very clean, and I think that's going to be really interesting for doing denoising and for even animation sampling later on. So it's really, really great the way that the Empath is producing noise. And then, in some of these, so these are mostly comparisons that we're looking at, between the default render and Empath. And, of course, a lot of these take advantage of the things that we're talking about that Empath's going to be good at. It's going to be good at ray tracing. It's going to be good at heavy geometry scenes. And in those more, I would say, kind of production quality scenes, you're going to see some really great speed ups. It is, worth noting that if you, open up the render, pop in a sphere or two and, start rendering, then, that's not necessarily going to give you the huge speed ups that maybe you're looking for. But in these nice production examples, many of them provided by Simon, thank you, Simon, we're seeing some really nice quality improvements as well as speed improvements.
Yeah, so I think, like we mentioned earlier, so this is coming out. You're going to be able to access it, everybody, in 13.2 when that's released, right? And you can pick it from the drop down. I think it's working with the default materials and the procedurals and gradients, so it's something that can be used right now. But really, this is where development is going to be loaded up on, right? Empath, not are we done developing the standard Moto Renderer? Greg, Alan?
I am.
That's the answer. No, but I mean, this is the technology going forward, right? I mean, we have a lot of things that we want to add to it.
Happening in the industry, everyone's moving in this direction.
Yeah.
All the big studios, this for production rendering, all the design renderers, all the GPU renderers. It's the way to go.
Yeah, so I think what this does is it gives Moto a modern renderer. It brings it up with the other path tracers that are coming out, both the third party and internally in studios, something people are familiar with. It's easier to use. It's modular. It'll be able to make use of different compute engines, potentially some different shading languages and things like that. And a little more flexible in terms of spitting out different render outputs and things like that. So it's really, it's a new renderer. It's easier to use. Going to be able to use the same materials, but ultimately, I think we're going to be able to take advantage of more varied hardware and hopefully more varied materials as well.
Yeah, I think that's a great summation of what we got going on here. I think at the end here, it is something we want to reiterate that this is not a full-blown or locked-in GPU renderer. We have some nice, GPU augmentation in there, which should give you some speed ups if you have heavy ray trace scenes and you have a nice, video card to work with. You don't need to have a crazy video card for that. But no one should launch this and think, oh, let me test this against Octane or whatever your, favorite GPU renderer is, because that's not. It's really what it's designed to be doing at the moment.
So in terms of, let me just follow up on that. So clearly it would be a challenge to give a GPU option for shading, but is that technically possible?
Yeah, definitely. Probably the first stage would be to port the most common functionality to the GPU, and maybe you wouldn't have all the exotic gradients or procedurals, but you'd have the 90% case covered.
Right.
And then it might even be possible to do a hybrid approach where some shading is GPU and some is CPU. I haven't thought about that too much yet, but at least we could.
Are you still there, Alan?
We just lose it, Alan. Yeah.
Sorry.
Oh, you're back. Okay.
Okay.
So
don't know what happened there.
So potentially even like maybe some things are supported on CPU, some things are supported on GPU, and those individual shaders are run on different engines.
Right. That might actually be possible.
That might be possible as well. Okay.
That's a really exciting piece, is to just not go down this one road where you're really locked into, either a very limited tool set where, hey, here's your renderer. It's awesome. It's super fast GPU, but here's your one shader you can use. You can't use the procedurals. You can't use anything else. You can't use gradients and things like that. To have that type of flexibility and still get the speed ups in areas where you need it or where the GPU is best. Currently, what we're looking at is the ray tracing speed is really exciting, and I think that it's a really interesting paradigm.
So I should ask, will this can you use Empath for baking as well, or is that not supported yet?
Not currently, but there's no reason why not.
Okay, so there's no technical limitation, so it could eventually be used for baking as well. I would assume over the next year or two, this is just going to be the Moto Renderer. I mean, this is what we're all going to be using. I would think.
I would not be surprised by that.
Yeah, unless you're loading up old scenes a lot or something. I don't know. Greg, anything to add to that?
We got lots of cool ideas we can't share on ways to make sure that this thing grows into something that is massively useful and flexible and satisfies all the questions that a lot of people are asking. So, I'm really excited about this as a new rendering framework because I think we've got a solution here that is unique compared to the other renderers out there in its, I guess, holistic approach. So,
just wrapping up here, are there any other rendering features on 13.2 we need to talk about, or is it just, I think was there an update to one of the new material? What's the scanned one?
Oh, the AXF materials. Yeah, we're continuing to expand our support of AXF. AXF, again, it's not supported. We're not supporting it per se in the path tracer in Empath yet. But yeah, we're continuing to expand that. You'll continue to see that to grow over time because that's very important to many of our customers. So yeah, we're pushing along in a lot of different areas related to rendering.
And Alan, one thing real quick before we go, we didn't really talk about subsurface scattering. Is that something that is going to need to be redone for the path tracer, or is that something that's sort of supported out of the box?
Well, we have it supported now in a way that should mostly match the old results. There's one option called same surface only, which is not quite supported yet, but I think it can be. However, there is potential for a much more physically based subsurface scattering with path tracing, which is actually unified with volumetrics. Volumetrics is probably the number one, probably the biggest feature that's not yet in the Empath. but I foresee a unified volumetrics and subsurface scattering solution in the future in Empath.
So this image I have on screen right now with these colored spirals do actually have the Moto subsurface scattering on there. So it did render, and it looks nice. So there's that, and yeah, I think I absolutely like any sort of modern or more modern solutions to these rendering effects that people are looking for, like subsurface scattering. And I'm looking at this as a product renderer. Being able to render products. There's lots of materials that exhibit some sort of subsurface scattering, and being able to have that available to us obviously would be pretty important.
Yeah, it should work now. Pretty similar to what people are used to in the current Moto renderer, especially if you model your objects without a lot of overlapping or intersecting surfaces. But this new solution I'm talking about is going to be like just super realistic and physically based. So I'm excited about that.
Nice. I like super realistic. Sounds good. Okay, I think we've sort of covered it all. We've introduced, sort of talked a little bit about Alan's past, and talked about the path tracer, which you can jump in and mess around with now, and sort of what it can do and what it can't quite do yet, and what it can do in terms of modularity and that sort of future-proofing that we're talking about. And I think the best way to end this is back on Alan's cats. Where are they? Oh, there they are. We'll wrap this up. What's the brown one's name again?
So we got the black one is Frodo, and the red orange one is Mimi.
Mimi. Wait, Mimi from just a Mimi?
The breeder named her that. It's not an idea.
Oh, okay. Not a just no Tolkien character name Mimi. Okay. All right, guys. So I think we're gonna we'll wrap it up here, and we'll put this up on YouTube shortly. And again, like I said, we'll put a recorded version, which hopefully will take care of any quality issues that weren't coming over streaming. And I guess let me just take one quick look at the chat. And I saw Rich, they were talking character animation over here, so I think we're maybe getting through. I think we're through this now. And okay, we're good. So thanks for joining us. Greg, when are we doing another 13.2 beta preview before the launch?
Yes, well, we're doing a couple more. So yeah, we got some cool stuff to show you guys in relation to modeling and a couple other areas. Because I mean, everybody who doesn't talk about bevel in this community, and so we've got some good stuff related to bevel in the form of chamfer. So we'll talk a little bit about that and a couple other things before the release.
All right, sounds good. So Michael, thanks a lot. Greg, thanks a lot. Alan,
thanks, Greg. Great to be here. Thanks, Greg. Thanks, Alan. Great.
If you're hoping to know what
Michael.
Alan looked like, you're out of luck.
I think there were a few shots in that slideshow.
I just got to throw this. I just got to throw this out there. It might have to do with James Darknell's notorious stalking about 8 years ago, chasing down Alan on the highway. That might be why.
Yeah. I remember that. Yeah, I think he saw your license plate.
The Ferrari in the license plate.
Yeah, the Ferrari with the Luxology license plate.
No, there you go. He got a job out of that. You can't blame him. So.
Yep, he did. But I mean, that was the best stalking job probably in history. But anyway.
All right, take care, everybody, and have a good upcoming weekend. And watch The Expanse. All right, thanks a lot. Bye-bye.
Later.
Thanks, guys. See you.